You should have maybe seen this, at least the juniors should have seen it, because this was on the old assessments, this was always tested on the old assessments, and they would give you this formula. But my question is, what's it mean to compound interest? If I tell you, you put money in your savings account and the bank's going to compound interest monthly, what's that mean they're going to do? They're going to increase it. Well, they're actually, what they're going to do is they're going to do your 1 month, they're going to calculate how much interest did you earn. They're going to add it into your account. They're going to actually pay you that money. So now it's in your account. So next month, when they're figuring your interest, you have more money in your account now, so you're earning interest on that interest. So next month, they add some more in. So now your account's got bigger again. So when they calculate interest for the 3rd month, you have more money so that you're gaining on it. Do you want them to compound a lot or a little? You want them to compound a lot. The more they compound, the more you make money, the sooner you can make interest on your interest. Okay, calculating that is very confusing, though. That's not like the old simple interest formula you did back in junior high. It's this crazy thing. So, bye. On the sheet, on the formula sheet, it tells you what all the symbols mean. If you lose this sheet, I did post this formula sheet on my webpage in case you need it. But P, in the land of investments, P stands for principal. What's principal? What is your principal? If you go to the bank and they want to know, they're talking to you about this, you're going to establish this account, and how much principal do you have? How much money do you have to invest? The principal is the amount you put in to start with. So or if you go to the bank and get a loan for your car, a $3,000 loan to help pay for your car, $3,000 is your principal. That's what your loan was based on, the starting amount. So principal is how much you either borrowed or how much you have to put in to start with. That is that's actually 100% is what it's doing. Okay, you're going to do the interest rate, and the N is the tricky one. N is how many times it's going to get compounded in a year. So if you're compounding monthly, what's N going to be? That's 12 times a year, so N will be 12. If you compound quarterly, every quarter of the year, how many times will that be in a year? Quarters are 4 equal parts, so you'll have 4 times a year, so N will be 4. So that N is how many times it's going to get compounded over the course of the year. All right, so how much y'all want to invest? $1,000, all right? At what interest rate are you getting paid? I want you to tell me where you can get 8% interest. I want my money there. Because these days, 8% interest does not exist. So, all right, we're doing 8% interest, compounded how often? Monthly, okay. And then, how many years are you going to leave it in your savings account?
7.
Okay, 7 years. So the question is, how much money will you have after 7 years? So all you're going to have to do is fill it in the formula. What's your principal? $1,000. Okay. You got 1 plus. Okay. Interest rate must be written as a decimal, not a percentage. So how do you write a? Thank you. 0.08. You move your decimal 2 places when you move a percentage. All right. What then? Okay, we're compounding monthly. It's happening 12 times. So you're going to put 12 there. You're going to put 12 there. The N has to be the same number in both places. And then the time is 7 years. So you'll have 12 times 7 up there. Okay, since we just made up those numbers, I have no idea what it comes out to. I don't suppose anybody was happily punching this in the calculator. Okay. So $1,747.46. In 7 years, how much money did you make just off interest? $747. Now, this assumes you don't take any money out of your account. Obviously, if you take money out of your account, you don't have as much to earn interest on. But, you know, that's what I said. If you can tell me where to get 8% interest, I want to know. It's like here in recent years, It's been less than 1% on an ordinary savings account. It's been horrible. Horrible. So, now, the book is actually going to also ask you to graph this so you can see what the exponential function looks like on your calculator. So if they said graph this to show how much money you would make over any number of years, I need you to realize, first of all, you're going to go to a graph page, and down at the bottom it'll say f of x equals. Okay. When you punch the equation into your calculator, yeah, you're going to have the 1 plus the 0.08 over 12. It'll do all that just fine. Okay. You want it to graph for any number of years. So if you have all numbers in here, there's no variable. It's going to that's just y equals a number. That's just going to be a horizontal line. You have to have a variable somewhere. It can't graph. Your variable is time. So if they said graph that, you would do to the 12 times x power. You have to have x is the exponent is your variable. We're doing an exponential function. So you've got to have a variable up there or it won't graph. So it's kind of important that you put a variable in. You may on these, in this case, this principle started at 1,000. If you're just under normal Zoom, are you going to see this graph? No. This graph is starting at 1,000. So if you actually, when you graph it, you probably aren't going to see anything on your screen. You're going to have, and I recommend probably changing your window settings on here. You might find it okay with zoom out, but you have to realize, if that started at 1,000, our graph is up here at 1,000, our asymptote. We started up here, we're gaining money. Actually, our asymptote's not at 1,000, it would be lower than that, but still, it's way up high. So you know you need to graph, this is $1,000 and getting bigger. So you would need to graph on your y-axis $1,000 and up to see this thing. Okay, and realize these things grow fast. So like we did, in 7 years we were at $747. I would guess big on how high to make my y coordinates go. Like this one, I might guess, let me see as high as $20,000. Because it could be, if you start compounding over many years, it could get pretty big. If they say graph from 0 to 20 years, then you're going to have to change your x-axis from 0 to 20 so you can see 20 years worth. But most of these are going to be bigger numbers. You're not going to see them when you zoom normal. You're going to have to adjust. And like I said, sometimes zooming out will work. Sometimes, if it's one that's growing really steep, by the time you can zoom out to it, it'll be doing this. You'll barely see anything. So it's better, particularly, it's better if you set your own x-axis. It'll spread it out. So you'll play with that a little bit. Not a ton. All right. The other thing, we have 2 other formulas on there, and I need to explain to you how to read those formulas. The second one is super, super useful, particularly in the business world, but the variables they chose in it don't tell you anything. They don't help you. So I kind of have issues with that one because it's not very helpful. All they gave you is that basic y equals a times b to the t. And a and b don't represent anything. Like here, p meant principal. It had some connection. A and b, I will tell you, on every single formula on that sheet, every single exponential formula, the first number is always the starting amount. Principal was our starting amount, and here, A is the initial amount. How much do you have to start with? This formula, I said business. This was good for any kind of, you're trying to figure out income in a business or company. It's also good for human population growth because humans, we control whether we reproduce or not. We're not like rabbits or something. So that goes into this category. You own antique cars. You want to figure out the increasing value of your antique car over X number of years. This formula. So anything particularly dealing with money other than compound interest, it's going to be this formula. The only time you use the compound interest formula, it must say in the problem the word compound interest. If you don't see those 2 words, you can't use that formula. So you can always have people who try to use that formula for lots of things. The thing that concerns me about B, that's your growth rate. And you'll notice on your sheet it says measured from 100%. That's really crucial. The fact that it's measured from 100%. And I'll show you why. I did research a couple years ago, and looked it up, and at that time I found out if you were going to go to K-State, tuition in 2002 for a year, an entire year, not one semester, but for an entire year, was $3,467. Okay, I then checked again and found out that in 2012, it was rising at a rate of 7.6% per year. So my question to you is, how much is tuition in 2014 if it kept growing at that same rate? So when you go to fill in this formula, y, of course, what it's equal to, by the way, is always your ending amount. It's on the left. So that's what we're going to calculate right now. What's our initial amount? Yes, our $3,467. Okay. The growth rate is supposed to be how fast it's growing. Okay, how fast is it growing? It says 7.6% per year. So what do I put in for the growth rate? Do I put in 0.076? That's how you write it in the decimal. Okay. We're going to try that a second. If you punch that in your calculator, it's simply just going to do for 1 year later, so that I'd made time be 1 year. I just want you to realize the common sense part of this. If I take that times 0.076, is it going to come out bigger? It's going to get smaller, 7.6% of something. Yeah. So when you want it to grow, remember when I said measured from 100%, you need to go, oh, I'm at 100%, it's going up 7.6%. That means I need to use 107.6% as my base. So that would have to be a 1.076 so that it grows. You got to be over 100% to get bigger. And then, okay, how many years would it have been from 2012 to 2014? Or 2002, sorry. 2002 to 2014 that'd be 12 years. So if you punch that in, you get $8,350. I'm rounding it off. Okay, that's actually a touch high. I just looked it up the other day. Here in 2013, it was like 7,700 for a year. So it's not quite growing at that rate anymore. They've slowed it down. They haven't increased it quite as steeply. But, guys, that doubled. Between 2002 and now, it's still doubled. Kind of scary how much that's going. Because inflation has hit our so that went up. I do want to double check on that formula. If I had said the population of Seneca is decreasing at 2% per year, what would the base be, that letter B, if it was decreasing at 2% a year? How would you figure it? You're close, but you're not doing your decimal right. How do you write 2? Yeah, because you would be going 100%. If you're losing 2% a year, that means you're keeping 98%. You wouldn't take it times 2% because 2% is something tiny. So you have to subtract it from 100. If it's decreasing, you have to subtract it off, and then so 98% or 0.98 would be your base. So you always have to add or subtract it from 100 whenever you use that formula. That's mission critical. Or you'll know you're wrong, but guess your answer will not even be remotely logical. Is that aspect of it.